Hi everyone, welcome. Good to see so many people. Hello, welcome to the Encode X Polkadot Educate series. This is our fourth or fifth event, if I'm not mistaken. Those of you who've been to our previous events, which I was attended and greatly enjoyed, may recognize that I am Isaac. I'm not Angela, who's the usual program manager, but I'm taking over this event from her. So really excited to see some great educate session. Hi guys, welcome as more people join. Hey, good to see you. Good to see so many people. Feel free to introduce yourselves in the chat and talk about why you're excited to be here. So I won't go on for too long. I think people are slowly filtering in. So just to say, welcome everyone to the Encodex Polkadot Educate series. As I said earlier, I'm covering for Angela, who's the normal program manager. Today is the fourth session, and our topic is an intro to Ink and Swanky, building Wasm Smart Contracts on Polkadot. So I think that's enough from me for today. So I'll hand over to Ash and Saša for today's talk.
Hi guys, I'm Ashutosh from Astar. So let's get started. So yeah guys, I'm Ashutosh from Astar Network, and today we will be having some introduction about Ink and Swanky and in general how to build Wasm smart contracts on Polkadot, what they are and the details about them. So let's start. So for the today's agenda, we will start with what is the Astar Wasm stack, because I feel that it is very important to understand that the execution engine and the constraint as a smart contract developer, because you really ought to know the granularities of how it actually works in low level, because at the end of the day smart contracts are very sensitive piece of code. So you have to know what execution environment you will be deploying upon and how it will be run. And then we will go through Ink and some toolings around this WASM smart contracts, especially Swanky, and then the networks around it. So let's start with the Astar WASM stack. So the first question arises that what is WebAssembly? Because there's a lot of talks about WASM smart contracts and inks and stuff like that. So first of all, what is WebAssembly? And first clarify that WebAssembly is neither web nor assembly. It has not no part of any of those things. It is simply a compilation target for the other languages. And to be more specific, it is a binary instruction for a virtual machine to execute. So it's not a language meant to be written by developers, but rather a target for existing languages like Rust, C++, and Golang. And Rust especially has first-class support for WebAssembly and has integrated it very well, as they both kind of complement each other in certain ways. Like Rust does not have any garbage collector and no runtime overhead, so it is quite easy to compile down into WebAssembly. So these languages can then be compiled into WebAssembly, which can be run by any virtual machine that supports it, and that will run same everywhere. So now we know what is WebAssembly, but why was there a need for it? Like, what is it trying to solve? So it was developed primarily for assisting JavaScript in web browsers. I won't go as far as to claim that it was to replace JavaScript. Nothing is going to replace that. So there are a lot of problems with JavaScript that WebAssembly especially aimed to solve, and that particularly was execution speed. And as the web platform grows from like simple web pages to progressive web apps and to full-blown games built upon WebGL, it became quite clear that scaling JavaScript for very high compute load would not would not work, and if not impossible, would be quite difficult to get around this. So the question arises, why not just build a specialized languages for this? And maybe this sounds fun, but not very practical, given how much fragmented and messy the entire web ecosystem was. And and build a new language on top of it meant developing support for it on existing browsers and onboarding users to this new language. And that would definitely be a challenging task. And there would also be need for some new entire set of toolings and frameworks to support this language. To simply put, creating more problems for solving another was not a viable option. So that's why we have WebAssembly, which other languages can simply be compiled into, and every browser can run that simple WebAssembly binary exactly the same with high degree of performance. So Now we know the reason why it exists and what it is, but what makes it exactly suitable for smart contracts? Why not just make something of our own, like what Ethereum does with Solidity? To answer this question, let's understand for smart contracts, we needed something with a secure sandbox execution. And WebAssembly is a memory safe and runs in a secure sandbox environment. It can only access interface that host provides, and its virtual machine does not trust the code it runs. So it's kind of check the box. And then we needed something with native performance. We want something performant, and WebAssembly can match the native performance. It is designed to be run near native performance. So it checks the box. Then we want something that does not depend on a single language. And lucky for us that WebAssembly is language agnostic and has wide language support, especially with Rust that we are so fond of in Polkadot ecosystem. So it's kind of check the box. And on top of it, all the big tech companies like Google, Microsoft, Facebook, Mozilla are supporting it. And in fact, continuously improving it. So it's not going anywhere, or rather, can only improve with time. And also, there is a huge community and tooling supports around it. So no need to develop a whole set of toolings from scratch. So that saves us a lot of resources. So that's why WebAssembly is ideal for smart contracts. And although it was not designed to be, but somehow happens to be. So moving on, we have this hierarchical view of our stack. It starts with the layer one, which is a substrate based node that has forkless upgradable runtime, which is usually a collection of frame palettes, as you might know, those of who are familiar with Polkadot. And then we have palette contracts. For those of who have background in Solidity, they know EVM is the execution engine for Solidity smart contracts. So in Substrate, we have palette contracts, which is execution environment for our WebAssembly smart contracts. It exposes certain APIs for the end users to deploy and interact with WASM smart contracts. And in certain aspects, I can confidently say that it is superior to EVM, such as in gas model, and the EVM bytecode is rather limited and slow as compared to WASM bytecode. And then we have the languages. In theory, you can deploy any WASM binary to palette contracts, given that it follows palette contracts API. But it is good to have some specialized EDSLs, which are nothing but simple meta languages built on top of existing languages that targets to follow certain rules and specifications which make it easy for people to write contracts, because then you don't need to worry about a lot of boilerplate code, and as it simply will be abstracted away by the EDSL language. So now you just have to worry about your contract's business logic, and the rest will be handled by and magically will be handled by this EDSLs. So for Rust, we have Ink, and for assembly script, we have Ask. And in fact, Ink is actually quite easy if you compared it to complex Rust paradigms. And even if you are new to Rust, I would suggest you can just simply start with Ink because it is so easy, all thanks to the magic of macros provided by Ink. So if you are beginner in Rust and you have almost basic knowledge of Rust, you can simply start with Ink, and you will get to know Ink and Rust in much better sense, because the time you can simply improve your skills. It does not require you to have any some advanced Rust skills. And for the Web2 developers and the TypeScript lover out there, we have Ask. It is based on assembly script whose syntax is very similar, if not same to TypeScript. You might feel at home as tooling around it is same as any other TypeScript project like NPM, Yarn, ESLint, etc. But one thing to note for Ask is that it is still under heavy development and quite bare bone at the moment, and absolutely not clearly ready for production. So if you have plans for production deployment, I would rather suggest you go with Ink for now until the Ask is ready for production. So just simply use Ink for now. And if you just want to play around, have some prototyping, you can do that with Ask, but nothing close to production. And then we have our standards, the PSPs, aka Polkadot Standard Proposals, which are managed by Web3 Foundation. They are similar to what we have in Ethereum, like EIPs and ERCs. So for the fungibles, we have PSP 22, which is ERC 20 equivalent. And for the non-fungibles, we have ERC7, we have PSP34, which is ERC721 equivalent, but better. It has better support for metadata. And then we have PSP37, which is equivalent for ERC1155, the multi-token standard, or you might know it by fractionalized NFT standard. So that's it for this hierarchy of our stack. Then moving on, this is the palette contracts execution environment for WebAssembly smart contracts. So there are three important things to understand. First, we have gas metering. So if you are familiar with any smart contract platform, you must know that you have to pay for contract execution. Doesn't matter which blockchain it is, you have to pay for the contract execution. It is same everywhere. And if you are familiar with how gas works in Ethereum, so you might find it quite different. In pallet contracts, it is very different, or I would say more advanced or efficient, as it separates the execution from the storage cost. So similar to how Substrate uses weights to charge the execution time of a smart contract, it employs the same technique for weights. So for example, if your smart contract uses 10 millisecond of execution time, it has to pay the weights associated with that time. So simply you pay for the time you use. And we have something called storage runtime, which is a cost associated with each bytes of storage you put on chain. So for every data that the smart contract saves on chain, the caller has to pay a rent for storing that data, and it will be refunded back when the storage is deleted. So it is more like your balance will be reserved or locked until you delete the associated storage from contract. And this is an economic measure that creates the incentive to delete the unused data from the chain, and thus increasing the storage efficiency. And, and basically it reduces the stale data and unused data from chain. And this is really helpful if you think about it. It makes the storage very clean, incentivize people to just remove the unused data, and overall it makes the storage more efficient. Then moving on, we have our execution engine. And this is the heart of pallet contracts, where all the WASM smart contract actually runs and all the magic happens. To run the smart contracts, which is basically a WebAssembly code, it uses WASM, which is a Start-based WASM interpreter to execute smart contracts. And you can ask a simple question: why are we using WASM here? Why not just use WASM time, which we already use to run our substrate runtimes? So there are few reasons for that. The first is WASM has very high degree of correctness of WebAssembly, which is rather important in terms of smart contract. The second point, it has very low overhead and very fast startup time for executing WASM modules. And if you think about it, when someone calls a smart contract, first of all, the smart contract's code is fetched from the storage and then it is run. So startup time is really important here. And it has very low startup time. So that's a plus point. And third point, it has built-in gas metering. So that means that it can calculate how much gas a piece of WASM code requires to run on the fly without the use of any instrumentation or hack. But as of now, it is not enabled in pallet contracts, but it soon will be. And the last but not least, it can run itself inside WebAssembly. Now, this is most important because if you think about it deeply, runtime in itself is a WebAssembly module. And we are running a WebAssembly interpreter inside a WebAssembly module to run another WebAssembly module. And yes, it is as complicated as it sounds, but somehow WASM managed that. So yeah, WASM is not the most efficient and the fastest out there, but it checks all the boxes. So it is ideal for use case inside pallet contracts. So that's why pallet contracts uses WASM. And moving on to two-step deployment. And this is something very unique to pallet contracts because it ensures that only one copy of any unique WASM code stays in the storage. That means that only one copy of same smart contract code will exist in storage, and any number of smart contract can be instantiated by it. For example, in Ethereum, let's say you have to deploy a ERC token. So what you have to do is first of all upload the same contract that many others have already deployed. And this is really inefficient to have exactly the same copy of code thousands or but tens of thousands of times. But here in pallet contracts, you first upload the contract and receive a unique identifier hash associated with that code. And then anybody can use that identifier to instantiate a new contract from that same code. And what instantiate does is create a new contract instance and along with it new storage group. So comparing it with to EVM, only one person has to deploy the ERC20 contract, and the rest can simply use that to instantiate their own copy of contracts for their own use instead of uploading the same code again and again. That way, only one copy of that smart contract rests in the storage, and multiple contracts can just simply use that code without need for deploying another. So this again makes the storage very efficient. So moving on, now we have known why how pallet contracts works and how its execution environment looks like. So let's understand what is a EDSL. EDSL stands for Embedded Domain Specific Language, and it is essentially, as I said earlier, a simple metadata language on meta language built upon top of other languages. So it's nothing more than a constrained version of other languages. So why is there need for something like that? Because there's something interesting in pallet contracts. Because of the use of the WASM, we have essentially decoupled the languages from the execution layer. That means we can use any language that can compile to WASM for smart contract development, be it Rust, assembly script, C++, any language we want. But it's not like that any arbitrary WASM code can be called a smart contract. In order to be a valid smart contract, a WASM binary has to be compatible with pallet contracts API. And what those APIs are, you can simply look it up in GitHub for pallet contracts. So yeah, that's why EDSL exists. They are here to make our lives easier because when writing smart contract, they will handle the API compatibility part and you just have to focus on implementing your contract's business logic. So in the similar way, Inc will ensure that at the compile time, your Rust code is compatible with pallet contracts API and ask will do the same for your assembly script code. And then finally, let's talk about Inc. It is supposed to be the main topic today. So in the left side, we have a simple Rust code. And on the right side, we have a basic Flippers Inc. smart contract. If you have never seen any Inc code before, you will say that it feels like Rust. Well, it does, because it is exactly the Rust with some magic macros on top of it. So on the left side, all there is a module with a simple struct. Here we have flipper struct and value is just a simple boolean. And we have three functions here, associated functions. First is new. It is a constructor. New is usually used for constructor, but you can name it however you want. And then we have flip and get. And the right side, we have all we have done is add some simple basic macros to our Rust code, and that makes it that makes it a simple contract. We have added inc contract macro on top of the module to indicate that this is indeed a smart contract, and then we have inc storage macro on top of flipper struct, and that indicates that this value will be saved on chain. And then we specify that new is our constructor by using inc constructor macro. It will be used to instantiate the contract. So it will be the very first callable function. And then we have inc message. It simply marks the function callable from outside the world. So it exposes functions to be called from outside the world. So now we know how inc works with macros. So let's discuss those macros in detail. So first we have inc constructor. This marks the method as constructor for smart contract. It will be used to bootstrap the initial contract state. And the good thing about Inc is that it allows for more than one constructor per contract. And this is really helpful if you think about it, because as many contracts can be instantiated with the same code, so having multiple constructor gives flexibility to everyone to choose which constructor is optimal for their own use case. And then we have Inc storage. So it annotates the struct to represent the contract's internal state that will be saved on chain. And just like EVM used the concept of storage slots to manage the storage inside a contract, In palette contracts, we have something similar called storage keys, which has similar functionality. So what this storage macro will do is simply derive the necessary traits for handling the key generation and pulling and pushing data out of storage and all the storage related stuff such as encoding and decoding. And then we have ink message. It simply marks the function of publicly dispatchable, means it can be called from outside world. And it is similar to Solidity public access modifiers. And then we have ink event. It is used to annotate a custom strut to represent a change in state, and that will serve as an event that can be emitted from any dispatchable functions you want, whenever you want. And then later on, the indexers or block explorers can use these events to construct your palettes and your contract storage in an off-chain database for faster access and for maybe caching, depends on your use case. And now we have tools, as we have discussed what a palette contract is and what is ink, what are its macros. Now let's discuss the tools around the Wasm smart contracts and especially ink. So for first, we have Swanky Suite, and it is all-in-one tool for Wasm smart contract developers. Here I won't go in much details because Sasha will go through this tool in much detail later on. Then we have OpenBrush. The OpenBrush is a library for smart contract development on Ink, which is maintained by a Brush FAM team. It is like OpenZeppelin for Wasm smart contracts, and it is exactly like what you would expect from OpenZeppelin. It has default implementations for PSP and along with all their extensions, and it has a lot of useful contracts implementation for useful contracts like time lock, payment splitter, etc. It also has generic implementation for trades around ink. So it is like an extension over ink. It also provides wrapper around trades which make cross contract call much easier and lightweight. Currently, if you want to make a cross contract call in ink, you have to import the whole contract as a dependency. So which make it rather, I would say, heavy or cumbersome. But this wrapper around traits feature by OpenBrush simply make it easy. You don't have to do that anymore. So now the contract calls are much easier and lightweight. And it also provides modifiers like only owner and other access modifiers and other modifiers. And you can also build your own modifiers with help of it. And then it has extensive documentation and a very good and detailed documentation about its macros and contracts. If you want to read the documentation by yourself, you can simply go to docs.openbrush.io. And also it supports upgradable contracts and provides implementation for proxy patterns and advanced proxy like diamond upgradable patterns. So yeah, and also it comes with a wizard-like interface where you can use it to build a full-fledged contract, mostly PSP contracts, by selecting options from UI. And it is really helpful if you want to just skip creating boilerplate code. Now we have the networks. So in Astar, we have many different networks. On the top left, you can see the Swanky node, and you will use it to run a local node to test your contract locally and to run end-to-end test or smoke test or integration test, maybe everything related to local development. And this is very similar to what Hardit node and Foundry's and Anvil is for Ethereum and EVM. And then at the further stage of your development, you can deploy your contract to our testnet Shibuya to test your contract in a more real-like environment. And then after testing your contract thoroughly on a testnet, you will be ready to deploy on Astar mainnet Wasm. As of now, you can deploy your Wasm contracts on Shiden. It's already live. You can just deploy it there. And very soon it will be available on Astar mainnet. And then now how to set up your Ink environment. Basically your Ink smart contract development environment where you can just build, test, deploy, and interact with your smart contracts. For that, you simply have to set up Rust, install cargo contracts, set up Swanky node, and you are good to go. And if you face any problems, you can simply check our build section in our docs, and it has very detailed instructions regarding this, and also very helpful tutorials for Ink. And while you are at it, you can follow Astar on Twitter and maybe join our Discord to stay up to date regarding Wasm updates. And now it's time to build. Your time to shine, Sasha.
All right, thank you very much. Great intro, especially considering your time zone. I suspect it's like after midnight
Yeah,
where you are, right?
it is.
All right. So, hi everybody. I'm Sasha, also from Astar, and I'm gonna show you in practice how does it look, what Ash just showed you on the slides. Okay. So, first of all, I want to show you the Astar docs on Swanky Suit. So, what Swanky Suit is, it's like it comprised of like two main parts. One is Swanky CLI, which is a CLI tool to basically automate most of what Ash was just talking about. I'll show you in a minute. And Swanky node, as Ash also mentioned, is a local node that you run that's optimized for local development. It has pallet contracts already in it, as well as pallet dub staking, which is something very specific to Astar, and among other pallet assets. And what's interesting about it is that you don't have to wait for a block time because it has instant seal and manual seal uh, integrated in it, which means like as soon as you push a transaction, it will create a block and you will get like instant feedback back. So those two tools together with a Swanky dev container allow you to just like go straight into developing smart contracts. And if you don't know what dev containers are, they're basically Docker containers integrated with Visual Studio Code. They have been created by Microsoft, but now I believe they're open source. So for more information, you can go to containers.dev. But how it works, basically, you just clone this repo here. If you go to our GitHub, you also find a lot of information how to get started. And once you clone it, you will see the same structure here. It basically only has the configuration in there, and the configuration is very simple. It instructs it to use the Docker file to get started and set some predefined software to install, and you can configure it as you wish. Like if you need Node or like some other tools, I don't know, Python or something, you can just add it here as a feature, or you can customize your Visual Studio extensions in there, or set up users or mount different folders in there. But let's not go too deep into it. I'll just show you how it works. So basically, once you start Visual Studio Code in that folder, you will briefly see the contents of the folder, but Visual Studio will recognize that it's a dev container and will offer you to reopen the container, to reopen the folder in a container. And now, when you do this for the first time, it will take some time, like 10, 15 minutes, depending on your hardware. And that's because it actually needs to create the container, install all the software from zero. But the good news is it will do that for you, so you don't need to do all the steps manually. And like as soon as it's done, you'll be ready to go in and work on it. Okay, so it's meant to be accessed through the Visual Studio console, but you can also, like, if you just call a Docker command, if you call bash inside it, you can check here on this tab, you can check the name of your container, and you can see I already prepared a command. So basically call docker execute in the current ln, call bash, and you will be transferred into the container. Now, it's important to note, like when you start a project inside a container, it's a different repo. So like it's not the container configuration repo, it's your project repo. So easy to get confused there. All right, so first of all, since you can see when we connect from here, it's a VS Code user, and the thing is, it's actually meant to use that user, not root. So we just switch here to VS Code, and we'll cd into the workspace folder where we have rights to do stuff. Okay, so as I mentioned, all I'll be talking about right here is described in the Swanky CLI docs here, so you can refer to those whenever you need some help. And also, like, if you run into problems, you're welcome to like open issues on the repo, or like try to search help on Stack Exchange. Just tag Astar Inc. or whatever you get stuck with, and also on our Discord we are patrolling there. So we'll probably be able to help you. Okay, so once we are in the container, our whole environment is set up, so we can check out Swanky. It's installed. We have a version 2.1, which is, I think is the latest right now. Right, so we'll just call Swanky init. We'll actually just call help, see what's available there. So these are the top level commands you can call from Swanky. As you can see, most of them revolve around contracts. So yeah, this is the kind of sub-level commands, but for now, let's call this one, which is Swanky init, to generate the whole project from start. We'll call it my project. I hope I have everything set up. Yeah, let's see how it goes. Okay, so it will ask us a couple of questions. Most importantly, what language we want to use. We'll use Inc, and we have a couple of ready-made templates. For this demo, I'll use Flipper because it's faster to compile, so we don't have to stare at my screen for a long time. We'll call it Flipper. This is my username from GitHub. It pulled it when it built a container. I will not provide an email. And yeah, we will download a Swanky node because that one is the default, and like we can guarantee it will work with the Swanky node. You are able to like use your own node or use like a third-party node, but yeah, you're on your own. Well, not on your own. You can ask for help definitely, but like Swanky node is the easiest to use with this tool. All right, it should download it, and now install all the dependencies. And you can see here it created my project. It's easier if you just cd into it. So we'll open a folder, and this is the like file system inside the container. So I just choose workspace and my project, and now it will briefly reload the VS Code environment. All right, and we are in. This is still installing dependencies. It should be done rather soon. And the dependencies here are basically JavaScript dependencies because Swanky project is a JavaScript project, Node.js project, TypeScript in this case. It just has constructs inside it, and this is where we find the one that Ash showed. This is a Flipper contract, which will now compile. So I'll keep talking while it's compiling. So we just call Swanky contract compile, and it's called Flipper. Oh, yeah, I have to cd into my project and call it again. All right, so while it's compiling, maybe I briefly go around the whole project setup. So as I already said, the contract itself is in the contracts folder. You can have multiple contracts as well, and depending on like what you want to do, Swanky will compile all of them for you. and it will set up tests, and it will include them in this Swanky config JSON here, which basically keeps track of all the networks which are defined here, and also accounts that you can use with your contracts. You can also create new accounts, both dev accounts that have like exposed mnemonic, or encrypted accounts, which you will be provided a mnemonic in the CLI standard output, and it's on you to keep it safe. Yeah. And you can see here now it's compiled, and what will it also do for you? It will generate TypeScript types using type chain, and that allows you to very easily write tests using Mocha and Chai, because the types are provided right here and are automatically copied when it's compiled. So now you can run test, but since test is actually deploying a contract and calling it, we need to run a node to deploy it to. And I'll just run a node here with the simple Swanky node start command. All right, so node is running, and you can see it's allowed. Oh, just a second. Yeah, it's here. It's automatically open the ports to outside of the container to my host system, and that allows us to go and connect to it from like outside. For example, contracts UI. You can see it's connected to the local node. All right, and since our node is running, we can now run test. Let's set Flipper. What this will do, it will just call all the tests inside the Flipper folder. Now there will be a warning about duplicate dependencies, and that's because both Swanky CLI itself and this test are using these Polkadot dependencies, and those packages have like a security check in there, like, are you using multiple versions of it? We are not using multiple versions, we are using the same version, but the warning is still there. As far as we know, it doesn't cause any like big problems, but we are still working on removing the warning itself. You will see it right now. Yeah, this is the warning, and you can see the tests are passing, and you can see here it did something on the node. It deployed the contracts and tried to call the flip, which I will now show you how to do manually. All right, so let's pretend that like this didn't happen and the contract is not deployed on the node. We will need to deploy it, and it's like super straightforward, which is called Swanky contract deploy. I'll call help just to show you how it goes. So what we need a contract name, of course, which is Flipper. We need to provide a account that will pay for that deployment. And we also need to provide a gas value and optionally arguments if the contract constructor requires those, and our does. So yeah, I'll just use the cheat sheet here for the gas amount. Okay, so what we do is maybe we start from here, deploy Flipper, account is gonna be Alice, gas I'm gonna paste, so -G means gas limit, and the only argument that it needs is a state, a Boolean state, so we're gonna pass through. All right, if I didn't mess up anything, I didn't. All right, so you can see here we got the address it's deployed to, and you can see here that the block has been verified. All right, And now that our contract is deployed, it's also reflected in the Swanky config. Here is the contracts flipper. It's deployed to this address on this node with user Alice. All right, and how to check if it's deployed? If it's working, I mean, apart from testing it, we can call it directly. So let's say Swanky contract. There's two types of calls. Like we can use a query that to just read the data, and we can also use a transaction to mutate that data on chain. We'll try query first. We'll query flipper for the get value, and if you check the contract code, you can see it has flip and get. Like flip is mutating, which means we need to call it with a transaction if you want to mutate the chain, and get is only reading the data. So let's read what's in there. All right, so the only state it returns is true, which is how we initialize it. Now let's try to use the transaction. Transaction needs a bit more data from us. It needs an account to call it, and it needs a gas value, if I'm not mistaken. Actually, we might make it without the gas. Let's try. I mean, without specifying the gas, it will use gas like as much as it needs to, but you can specify like the maximum value you are willing to provide. Let's say flip. Yeah, and we need to provide the account which will lose money. This should be enough. All right. Yeah. So the result of the transaction is a bit different. It's a bit more raw, but what you want to look at here are these error values, and they're both undefined, which means there wasn't an error, and the block was finalized, which means it's written to the chain itself. Yeah, we are like the whole of Swanky is still a work in progress, so this will probably get more like nicer in the future. But for now, it's here, and we can like check the query again to see. Yeah, now it's not. Now it's false. It was true here. So we have successfully flipped it. All right. So what else? Let's see. You can, as I mentioned, you can add new. Oh yeah. One thing I also want to show, like, since this is a like closed environment, within the container, we are providing like a escape hatch from basically mounted folder, so you can send those files to the host system. For example, if you want to, why is this still okay? If you want to instantiate a contract through the contracts UI, you will need to drag and drop or upload a contracts file, and the way you do it, you can see that there is a host home folder in the root. So basically, if we copy the contracts folder from there and flipper contract to host home, this one will be mounted on your home folder /Swanky. By default, you can modify it in the Swanky Swanky dev container config. And now, if you want to do it from here, we can upload a new contract. Oh no, we will actually use it from the address because we have already added it. Where was it? We can check the Swanky config. It's this address. I'll copy it over here. and I'll call it new flipper, or let's call it flopper. All right, and I'll just drag this one in, and now it's the same contract, but only we are viewing it through the contracts UI. And if we call get, we'll see it's still false, which is how we left it. Right, so a couple more features I can show, maybe Swanky account, we can list them. We have Bob and Alice, and let's say we want to create a new one. See, we have a couple of options, but create is the one we are interested in. Let's see how to create it. So we can either provide a mnemonic or have it generated for us. And as I mentioned before, it's either a dev type of account, which is like unsecure and has plain text mnemonic in the config, or non-dev, which will ask you for a password and then it will encrypt the mnemonic. And without a password, you won't be able to access it again or interact with that account. Let's create a dev one, and we will not generate, but we'll use the pre-existing Charlie account. All right, so yes, it's a dev account, and its mnemonic is Charlie. Or is it just one slash? Oh, it's two. All right, it's gonna be called Charlie. All right, so now we have Charlie as well, which means now we can call, let's say, flip again. But now Charlie will flip it. There, Charlie flipped it. Thanks, Charlie. All right, did I miss anything else? Let's see. Are there any questions, by the way? Yeah, there is one. Ash, maybe this is more for you, but the question is.
Yep, I already answered that.
Okay. I did not see the answer here. Okay, so let's check here. Okay, this is the full list of commands. Yeah, there's also the plugin section, which I didn't talk about, and this is because it's still kind of early in there, but we aim to make Swanky as pluggable as possible. So, for example, you have your own functionality you want to add, or like something very specific for your contract or your chain or something, you'll be able to add it to Swanky. For example, Fala is right now working on a plugin that will allow you to download the Fala node or like start the Fala Fat contract or interact with that as well. Yeah, I think I covered everything. So unless there are any more questions, just as I mentioned, you're welcome to post on Swanky GitHub, post any issues or problems or for questions, either our Discord or Stack Exchange. Yeah, we'll do our best to help out.
Cool. So thank you so much, Ash and Saša. I think maybe we'll give it a minute or so, see if anyone has some questions in the chat. So if anyone has anything they'd like to ask, this is a fantastic opportunity. Just say thank you again, Ash and Saša. That was a really fascinating deep dive into building with Ink and Swanky. So particularly if people have kind of practical questions, now is a really great time. You've got some excellent.
I think we have a question here.
Okay, awesome.
So I think I'm currently using Windows 11 and it works perfectly fine for Ink. But the caveat is that you have to use WSL2. So obviously the Windows doesn't not play nicely with all the VS Code and setup. So it would be better if you are using Windows 11. So just have WSL2 installed and start VS Code inside it. And it's exactly the same as any Linux environment.
Or the dev container. I believe you can run dev container in the in Windows without
but
yeah.
but that still needs WSL2 because the new Docker in Windows requires you to have WSL.
Okay.
So yeah, just make sure you have WSL if you have Windows.
Cool. Thanks, guys. Thanks, Connor, for your question. Let's see if anyone else has anything they'd like to ask. So maybe it would be great if you could talk a little bit more about just kind of getting set up with building like right from the start, maybe for people who are less experienced developers, or perhaps people with a background more in like Solidity, how this kind of maps onto that.
So yeah, so if you are someone who have absolutely zero background in writing smart contracts, and even if you are new to Rust, so I will suggest simply just go to our docs. We have very simple docs. It's like zero to hero. So from the very start, do not need any prior knowledge of Rust, Inc, or any smart contract development. You can start from the level 0 tutorial, and then if you are comfortable, then you can simply just go level 1 up and up. And we have from beginner to intermediate to advanced level tutorials on our docs. I will share this in the chat. So you can go through that, and it is very detailed and it will help you if you have no prior experience.
Cool, that's really helpful. And I think a lot of people who might be new to building on Polkadot, who haven't used Wasm Smart Contracts, might find that really helpful. I think maybe we'll do a last call for questions. Yeah, perfect. So Ash has just sent the zero to hero docs in the chat.
So this doc has 3 tutorials. First one is Flipper, and that is very basic. You do not need any prior knowledge. And the next one is building a text, I guess. Let me see. The next one is building an NFT smart contract. In Polkadot, it is called PSP34. And after that, an advanced level, it's like building a whole Unisoft version 2 in Ink. So yeah, it's like everything. You after doing these 3 tutorials, you will be very comfortable in doing anything else.
Okay, that's fantastic. So thanks very much for your really insightful presentation. I'm sure people took a lot from that. I wondered, do either of you have any final words? Would just like to say thank you. Close up.
Yes, so from our side, well, it is going to be quite exciting times. Well, finally, pilots, Wasm smart contracts will going live in Astar very soon. So hold your horses. Many new projects and many new, I guess, Ink smart contract projects will be live on Astar very soon. And you will get to experience how I would say superior the Wasm smart contracts are as compared to Ethereum ones. Yeah, exciting times for Polkadot ecosystem.
Cool.
Absolutely, yeah. I agree.
Amazing. Thank you so much, guys. You've been great. I know I've learned a lot, and I suspect everyone else has as well. I've dropped some links in the chat, so you can check out the following sessions in this Educate series. There are certainly a few more to go. Make sure to check out Ash and Saša on Twitter with the correct Twitter handle, which Ash, you might want to send. I think I sent the wrong one again.
Yes. Just put an underscore in front of Uriki Otaro.
Amazing. Thanks, Omji. Cool. Okay. Thank you so much
also,
for coming.
Thanks, Isaac, for having us.
Thank you. You've been
nice
amazing.
Thanks.
Great to talk to you. Cool. Okay.
Right.
Bye, guys.
Bye.
Bye, guys.